Hello everyone, and welcome to the Dream Academy. Today we'll be talking about tangent and normal lines, as well as implicit differentiation. This PowerPoint is done by Karim Saeed and Alex Ward. First, we're going to start with the implicit differentiation, the process. Use explicit differentiation techniques to find the derivative. The chain rule will produce more than one dy dx. Collect all terms with dy dx to one side, all other terms move to the other side. Solve for dy dx. Factor out dy dx if necessary. GS, the greatest common factor of dy dx. Solve for dy dx by dividing. So, the implicit differentiation is used when there are two variables. For example, if there's an x and a y, and you're trying to find the derivative, in that case, the x you would use normally, and then the y, whenever you find the derivative of it, you would add dy dx, just because there are two variables present. We're going to start with some examples. So we got 3xy plus 5x squared equals 0. This is a product rule since x and y are being multiplied together. So we're going to do 3x plus the derivative of y, which is dy dx, since it's the second derivative, since it's the second variable, plus y times 3, which is the derivative of 3x. And then the derivative of 5x squared would be 10x, because you would multiply 2 by the 5 on the front, will give you 10, and then you'd subtract 1 from the top, and it will give you 1x to the first power, which is x, equal to 0. And then we would simplify by putting the 3 in front of the y. Then we would move the 3y to the and the 10x to the other side to isolate dy dx. Divide by 3x, and this will give us dy dx equals to negative 3y minus 10x all over 3x. For our second example, we're going to do x squared plus xy minus y squared equals 1. Again, xy would require us to use the product rule. So the derivative of x squared would be 2x, because the 2 will go in the front, subtract 1, which will give you x to the first, which is x, plus x times the derivative of y, which is 1 dy dx, plus y times the derivative of x, which will be 1, since though x is technically an x to the first power, we'll move the 1 to the front, and then the x, you subtract 1 from the power of it, so it will be 1x to 0 power, which will at the end go to 1. And then the derivative of y squared will be negative 2y dy dx. That is because it is another variable, so we have to add the dy dx portion of it. And then we're going to simplify the equation. We'll isolate all the values that have dy dx on the left side and all the ones that don't have dy dx on the right side. And we factor out dy dx, and we divide. So we get dy dx by itself, and that will give us the answer, which is negative 2x minus y all over x minus 2y. Now, implicit differentiation, when you learn how to use it, you can do cool stuff like finding the derivative, for example, of this heart. Because since this heart contains an x and a y variable, for you to find the derivative of it, you have to know how to do implicit differentiation, and that's one of the benefits of learning it. Second, implicit derivative. So now we're gonna find the second derivative using implicit differentiation. So the process is pretty similar. The first 4 steps are exactly typical. But then, after you find the dy dx, you get the derivative of the derivative. And then, after you get the derivative of it, you have to substitute the first derivative for dy dx, and then simplify until the original problem is given. That is given to you is in the part that you simplified, and you just substitute it in, and then simplify if necessary. And then just be proud, because you have found the second derivative. So, our first example. So, we're going to find the first and second derivative of x squared plus y squared equals 16. The derivative will be 2x plus 2y dy dx, because it's another variable, equal to 0, because the derivative of 16 equals 0. And then 2y dy dx will be on the left side, and we move negative 2x to the other side, which will make it negative 2x. So we can isolate dy dx, and then we divide, which will let dy dx be by itself. Now we're halfway there. This is what we did in the beginning. Now we have to make a second derivative. So, in order for us to do that, we have to use the quotient rule to find the derivative of the derivative. For us to do that, it will be low d high minus high d low over low low. So, low is y. Derivative of the top, derivative of negative x is negative 1, minus high, negative x. And then derivative of the bottom, which will give us 1, but since this is another variable, will be dy dx. And then over low low, so y times y, which is y squared. And then we have to substitute dy dx, because we have it right here, and this will eliminate some of the variables we have up there for us to be able to solve. Substitute. So, we gotta simplify. Negative y minus x dy dx y squared. And when we substitute it, it will be negative y minus negative x, and then the substitution part, negative x over y squared. And then we have to find a common denominator between the two top in order for us to combine the formula. So for us to have a y on the bottom on the left side, we have to multiply by y on the top. So it'll be y squared over y. And we combine them, which will give us negative y squared over negative x. And then the y's on the bottom will combine with the y squared on the bottom here, and will give us y cubed. Y to the third power. Negative, we take the negative out, and then look at that. You get y squared plus x squared, which is right in the original. So we can substitute that value, and then it'll give us negative 1 times 16 over y over 3, which will give us negative 16 over y to the third power, which means you did it. Now find the first and second derivative for 2xy minus y squared equals 3. 2x dy dx, because we're doing product rule again, plus y times 2, because y and then the derivative of 2x, which is 2, minus 2y dy dx, because it's another variable, and I'll also include right here because y is the second variable, so we had to do dy dx equal to 0. 2x dy dx plus 2y minus 2y dy over dx will be a simpler version of writing it, because we can move 2 to the front. And then we move everything that doesn't have a dy dx in it to another side, and keep everything that has dy dx in it on one side. Then you factor out dy dx and divide to isolate dy dx. Then you have to do quotient rule to get the derivative of the derivative. So x minus y, low, derivative of the top, the y is another variable, so it'll be dy dx, minus negative y, 1, minus negative y, which should be the top, and then the derivative of the bottom, derivative of x is 1, and the derivative of negative y will be negative dy dx because it's negative 1 and it's another variable, so we'll put dy dx for it. And then the bottom squared, x minus y squared. And then we have to simplify. So we would multiply these terms together, which will give us negative x dy dx plus y dy dx minus, and then we multiply these terms together, negative y plus y dy dx. After that, we have to distribute the negative value, and then the plus y dy dx and the minus y dy dx would cancel out. So we'd end up with negative x dy dx plus y over x minus y squared. The dy dx needs to be substituted with the value that we found in the beginning. So we substitute it in, and we need a common denominator for us to combine them. So when we put a common denominator, the top for y to be combined with the rest of the for the rest of it over here, we would get x plus xy plus xy minus y squared over x minus y, and then over the original denominator. Then we combine. So x plus y and x plus y will give us 2x plus y. And we have to substitute in the original because it's given to us right here. And then when we substitute in the original, it will be 3 over x minus y over x minus y squared. After that, x minus y and x minus y squared will combine x minus y cubed on the bottom. And you are a master now. So this will explain more of the relationship of the derivative and second derivative. So the derivative of a formula would be the rate of change, but the second derivative is the rate of change of the rate of change. So in this case, if this is the derivative graph, then the rate of change over here will be 0 at this point right here because the rate of change of the rate of change is not changing. Tangent and normal lines. The process. First, figure out the value of x and y by substituting the other value in the original equation. So if we're given an x, we put in the equation to find a y. If we're given a y, we put in the equation to find the x. Find derivative of the equation using explicit rules. So we just do find our derivative, and then simplify and isolate dy dx on the side of the equation. Substitute in the values of x and y into their variables. Write the tangent normal line using x and y values as well as the slope. So if it's a tangent slope, the dy dx will be the slope, and if it's a normal line, then the slope of it would be the negative reciprocal. And then for example, we would